Hi, everybody. My name is Lena, and I'm from MTS AI. I'm going to talk about how we were generating dialogues and why we started to do it in the first place. Recently, chatbots have become a trend and used in many companies to solve different technical issues and to ease up the load of their operators. One of the ways to implement those bots is to use regressive language models. Well, seemingly it's all very simple, and you have a big set of dialogues.
You put it into a model, and then you have a bot as a result that can speak about the meaning of life with you. But it doesn't. It doesn't as simple as it seems. Sometimes bots are generating offending conversations, and for business, it is not acceptable that for such bots we cannot set a scenario beforehand. So going from bots based on a set of rules is a challenge now, and it's one of their advantages now. The bot is following the scenario you set, but from the other hand, in order to create such scenarios and rules, you need scenario scriptwriters and linguists work quite a lot of work, and sometimes there are mistakes in such scenarios. Yes, everyone wants to control bots, linguists, scriptwriters, and create simple scripts or make the whole process easier. And it is not surprising. Everyone wants to have simple tasks. So things like recipes, video recipes, never starts with digging out potatoes from earth. They just start peeling it immediately, and now we are using ready-made dialogues to go on. In scenario scripts, we mean a number of rules that the dialogue is set by, and the dialogue can also be defined by the emotions and the amount of data that is articulated through the dialogue. So the idea of our operations is based on the following. Since the regression models can reply to words of users understanding the context, it means that they store such encoded information. In order to check the assumption, we want to take the internal condition of the dialogue and save it as a structure, and then use the structure to formalize the scenario and check whether it is adequate at all, just trying to start dialogues using it. The bad news is that in order to check the structure for adequacy, you need adequate people, but not all of them are ready to do it manually. As a model that we take for basis is a DialoGPT medium, and it is autoregressive as GPT-2, and one path means one token that is added to input and is a sequence of decoders and multi-layered transformer architecture, but it can be trained on the set of dialogues. And we have such set of dialogues. We used dialogues from tech support MTS service for mobile services, and the amount of data is enough to train DialoGPT and then work with the structure. It contains dialogues of clients with operators where people come and try to resolve problems they face. Sometimes they succeed, sometimes they don't. And I think among you there are people who participated in creation of this data set. Thank you very much. We value it very much. So in order to highlight the structure of the dialogue, we can look at the hidden content of the model. So they are the hidden states of the model, and they go as embeddings. Then we clusterize the vectors, and then we identify the transitions between the clusters based on the information on transitions between the utterances of the dialogues, and this will give us the structure. So the next step is to know how to have it as vector of fixed model. Medium model is having 64 decoders inside, and token B1 positional decoding of the input token. And then going through the first decoder, as a result, we have a vector of fixed size, and then it is input for the next decoder, and that's the whole chain. And the last decoder result is the vector that is multiplied by matrix of token embeddings. And as a result, we have the distribution of probabilities for the tokens of the library. And in this structure, we're interested in vectors that are output for decoders, and their number will depend on the length of the input sequence, and we do not know beforehand what decoders we should look at. And in order to understand where we should go and how to change these vectors into a fixed-sized vector, we tried to Google and try and find on the internet the answer to this question. And we didn't find anything better than just work of Stanford University. They proved empirically the higher the layer, the more contextualized the tokens are. But this is the whole idea of the work, and then you should just think on your own. But, well, guys, you're Stanford, why not giving us the results? But we looked at how it is done for other models. Mostly those are the means of transiting tokens from last layer or several last layers, or using a special token, or the last token from the last layer, and this is end of text token in our case. And initially we basing on the fact that the more contextualized A's interface offered our utterances as vectors and tried to look at what it gives us, whether we have clusterization or not. After clusterization, can we have adequate clusters as a result? And we first started with algorithms that automatically define the size of the clusters, and this experiment didn't give us any good results. The quality of clusters was not very high quality. Some methods were not able to cluster the data set, but DialoGPT can identify speakers depending on the context and the initial utterance, and that's why we decided to clusterize this amount into 2 clusters, and our idea was proved. We have 2 data sets with clients and operators. And after this, we applied the algorithms again with automated select of clusters, and this gave us adequate result from the point of view of content of the clusters and their meanings and the number of outliers. But even such approach didn't give us an ideal result, and clusters sometimes had samples that did not fit in terms of meaning. We tried to find such samples. It is much more important than to assign them to a cluster. That's why we use the metrics, the silhouette of which allows us to define how well this sample is fit into cluster, and through empirical ways, finding the threshold and further clusterization, we get rid of the utterances that do not fit in, and the remaining utterances stayed. And this approach allowed us to have the best result. And after we define the clusterization, we can start experiments with the transformation of hidden states. And the best means here is to use end-of-text token or concatenation of the tokens of several layers, but it enhanced the number of calculations, and it worsened the result. That's why we said no to it. Other manipulations with tokens of last layer or tokens of several layers worsened the results of clusterization very much, and that's why we also got rid of them. And as for quality of clusterization, we looked at the amount of context that should be looked at. When training DialoGPT, we used 28 tokens context. This is around 4 sentences. And according to our experiments, it showed that the best clusters is when we use context of 1 or 2 sentences. If clusterization without the context, the clusters are not defined, or the quality was very bad in terms of meaning. And this experiment also helped us to see some other things, like the following. The more context we use for clusterization, the larger clusters, the more clusters go to initial dialogues. So it means that end of text token is in the context and it impacts the combination of the clusters. Another conclusion: the data set does not offer any variety in utterances of clients. They are sometimes very similar to each other, or the same linguists get said. But for us, it helped us to understand that such utterances sometimes end up in various clusters, and it happens when the context of these utterances have various meanings. For instance, for first two sentences, yes, the context had the meaning that the user was asked about the number he is calling from, and they went to one cluster. All three last yes had another meaning. The context had another meaning. They asked users whether, and the clusters look like this, and it helped us to prove the fact that the meaning of the context is coded in the vector, and in clusterization this factor is considered. And showing the utterances like this through vectors and clusterizing them, having clusterized them, we can have the structure of the dialogue and show it as graphs. In such graph, every utterance is the top of the graph, and the edges is the transitions. And to know how to set the edges between the vertex, let's have a look at 1 and 3. They are similar utterances of the same dialogue. So V3 vertex is in the cluster with V4 and V5, and we think that the context of this utterance and the utterance itself is similar to those they sit in the same cluster with. That's why we can add edges between V1 and all others that stay in the cluster of V3. And for more convenience, we add start and end points, and this will give us oriented graph. So such graph, we hope that such graph is enough to generate fluent speaking. So in this graph, the dialogue is the path from start to end points. But for us, it is interesting to generate dialogues that are not yet in the data set, that are different from those and have different structure. And in order to improve the probability of such generation, we can assign weights to the edges. So we make it in a way that between the vertex of the same dialogue, the edge has V1 weight, and all other vertex, the weight is randomly taken from 0 to V0, but V0 should be much less than V1 than 1. And on this we can generate dialogues. For them to be different, we need a method that generates various paths in one case. And here we use the K as the generator of the shortest paths. If it is important that generated dialogues do not contain utterances of the same input dialogue, we can make post-processing and set the limitations and just get rid of such dialogues. And everything goes well except for the fact that the generation depends on the number of vertex. And in order to change that, we took Dijkstra, but if we generate K paths, we will have the K similar paths, but we need various dialogues. And in order to change that, we used the end colony optimization algorithm. We just made the paths less attractive. And for each next Dijkstra path, we increased the weights of the edges. And Dijkstra found on the next step found not the same path but an alternative one. And after a number of iterations, you can assign weights by the method I described before. And at the end, such generation gave us this type of dialogues. And yes, there were a lot of them, too many of them, and we analyzed a large number of them, and the majority was not different from the initial dialogues. And actually, human beings cannot understand whether it is a generated dialogue or it was generated or it was an initial dialogue. In structure and the length, they were different, and the linguists said that the quality is quite high. But yes, there are mistakes also, failures also. The first type of such mistakes was related to the following. When clusterizing, we did not consider the gender of the speaker, but this can be fine-tuned through post-processing, and or ask operators why they did not ask us questions. Another type of mistakes is that we use a limited context when clusterizing. Automatically to correct such mistakes is a challenge, or it is sometimes impossible, and that's why we need some validation of dialogues. And if we look at what we have as a result, the method that allowed us to generate dialogues with various structure and the quality of such dialogues was assessed quite high, and the mistakes occurring can be fixed through post-processing, but part of them need validation. And we also show that the hidden content, hidden states of the model has some context in it, and it can be used for generation of the dialogues. And also we showed that the integrity of such dialogues is based on the context of the utterances, and we'll look at how they're related in the initial dialogues. I'm talking about concussionating. And the fluency of such dialogues is quite high, and this is because the clusterization method we use is quite costly. But it is okay, because you can use this method for small data sets or pre-calculate vectors and the clusters. And of course, what we've done has several areas of application and development. From the point of view of research, we would like to move forward with our experiments in interpretation of the model and its layers, and of course we want to modify the preliminary structure in order to apply it in bots and generate the scenarios that can be used directly. And this can be used to generate new dialogues and select scenarios for them and for the context paraphrasing. But in order to do something for research, you need the business to be satisfied. And for business, we can offer assessing activities of the operator, how far away he is from the structure or he is in line with it, analyze real scenario cases, its frequency, and show them in an illustrative manner for the business. And in theory, of course, lower labor hours of linguists and a lower number of mistakes when implementing and executing such scenarios. So that's it from me. Thank you very much. I will be happy to answer your questions if no technical. Elena, thank you very much for your presentation. I hope you can hear me well. Yes, I can hear you. Very good. So I would like to ask, you selected such large model, and much time was spent on understanding how to extract good data from it to get to clusterization. And the question is as follows. Did you compare it with simpler methods? Because it is interesting to know how, the work needed for using large models like DialoGPT, whether they're comparable with TF1 if you make clusterization through it. We didn't make such a comparison just because the idea of such experiment emerged due to the fact that just for experimenting, we trained DialoGPT on this data set to look at what dialects we can generate, and we realized that the model understands the context that generates responses adequately, and we tried to just extract the context from the model to skip manual extraction, but use the model instead. And we thought that, well, probably complicated models can save such information comparing against the simpler ones. That's why we didn't look at those. And did you compare those scenarios that emerged? Are there any scripts for operators? And did what you highlighted, did it coincide with what people use in their work? How close it is or how different it is, one from the other? We don't yet have such comparison, but we have everything in place to do it. You know, how script looks like for the operator looks very similar to the structure we have as a result. And after approval from the side of the business, we want to start with this exactly and try to modify the structure to generate the stories in RAS, for instance, in RASA. Very good. Thank you very much for your presentation. Very interesting discussion after it. Everything worked well technically. Well, I hope to see you on the next conference. Thank you very much. Thank you. I'll be happy to meet you again.